Imagine you're hurtling through the pitch-black night in a massive steam locomotive. The year is 1914. You're the engineer, staring out into the darkness, and you are relying entirely on a series of tiny colored lights to tell you if the track ahead is actually safe. Suddenly, you see a bright, clear white light pierce the darkness. Now, by the rules of the time, that white light means the track is completely clear, so you keep your speed up. But that light is lying to you. A massive, devastating crash is literally seconds away. In this explainer, we're going to uncover the hidden history of the traffic signal. It's this invisible infrastructure that was forged not just by brilliant invention, but by fatal tragedies, exploding gas lamps, and, believe it or not, the fundamental physics of the universe. Okay, let's dive into this. To understand how we ended up with the red, yellow, and green lights we see on literally every street corner today, we have to look at that 1914 train crash. You see, in the early days of railroads, the color white was actually used to indicate safety or go. And honestly, it made sense at the time, right? A clear, untinted flame was the brightest and easiest light to produce. But this system had a terrifying, fatal flaw. In 1914, on a dark night, a red glass lens in a railway signal accidentally cracked and just fell right out of its fixture. So with the red glass gone, the naked white bulb behind it was fully exposed. The approaching train engineer saw that white light, interpreted it as the clear-to-go signal, and sailed right through what was supposed to be a strict stop indication. The result was a horrific collision with another train. Just think about the literal hardware we're talking about here. These early railway signal lenses were essentially just really fragile pieces of colored glass. That thin, breakable layer of glass was literally the only thing standing between safe passage and an absolute disaster. The 1914 crash was a brutal wake-up call. The railways realized that relying on the absence of color, just a plain white light, was a completely terrible idea. Because if a lens broke, or even if an engineer just confused a distant street lamp or a bright star for a signal, lives were lost. The system simply wasn't fail-safe. To give you some context, back at an 1841 convention in Birmingham, England, railway engineers had established the original color guides. So red meant danger, green meant caution, and white meant safety. But because of the 1914 tragedy, the railways knew white had to be completely eliminated as a go signal. There was just no way around it. So they made this monumental shift. They moved green, which had previously meant caution, over to mean go. It was a decision quite literally written in blood, and it fundamentally altered the color language of the entire world. Section 1, Blood, Fire, and Physics. Why was red chosen for danger? Now, what's really interesting about this is how we shift our focus from human tragedy to the fundamental science of our world. So, we know why white was abandoned and why green became the new go. But why was red chosen for danger in the very first place? Like, why not blue or purple or orange? The answer is this fascinating combination of biology and the physical sciences. Part of the answer actually lies deep in our DNA. Thanks to evolutionary psychology, human beings are hardwired to notice the color red. Our ancestors who could quickly spot the red of a poisonous berry, the sudden flash of a dangerous fire, or the red of blood, well, those were the ones who survived. In fact, our eyes process red with incredible speed through something called pre-attentive processing. That basically means red pops out from the background before our brain even consciously focuses on it. But human psychology, that's really only half the story. The rest comes down to pure physics. In the visible light spectrum, colors travel in waves, and red has the longest wavelength of any color the human eye can see. And this brings us to a really crucial physical phenomenon known as Rayleigh scattering. Because red's wavelength is so long, it scatters the least when it passes through particles in the atmosphere. Shorter wavelengths, like blue, they just scatter in every direction, which, by the way, is exactly why the sky looks blue to us. But those long red waves, they just plow right forward. And here is why this matters so much for safety. Because red light scatters the least, it can penetrate environmental obstacles that would completely swallow up other colors. We're talking cutting through heavy fog, blinding rain, and thick dust. It remains visible from significantly longer distances than any other color. In fact, back in 1904, the Corning Glass Company did a study proving that smoke and dust particles actually lead to the reddening of every color aspect. Think about that. If green had been chosen for stop, a dirty, smoggy atmosphere might have made it look red anyway. Red is, without a doubt, the absolute ultimate warning color built right into the fabric of the universe. Section 2, The Exploding Semaphore, Taming the Chaotic City Streets. So we have the rules and we have the colors. But how did this whole system get from the railway tracks to the city streets? Let's step away from the trains for a second and transport ourselves over to the chaotic, heavily congested streets of London in the 1860s. Before the automobile was even invented, the streets were a dangerous nightmare. You had horse-drawn carriages, pedestrians, and streetcars, all just jockeying for space with absolutely zero regulation. So, a railway manager named John Peake Knight decided to bring the order of the railways to the chaos of the streets. In 1865, he proposed a semaphore signal. Fast forward to December 1868, and this massive 20-foot-tall contraption was installed right outside the Houses of Parliament. During the day, wooden arms signaled traffic. At night, it used red and green gas lamps operated manually by a police officer. And it worked brilliantly. Well, for about a month. In January 1869, a gas leak in the hollow iron pillar caused a massive explosion. The poor police officer operating it was severely burned, the device was ripped out of the ground, and the whole concept of traffic lights was essentially paused for another 50 years. Section 3. The chaotic transition to cars, standardizing the Model T era. Let's move to the 1920s and see how this builds into the system we actually use today. We cross the ocean to the 1920s in America. The automobile has officially arrived. The Model T is rolling off the assembly lines, and American streets are undergoing this violent, chaotic transformation. You have fast-moving cars mixing with slow-moving horses, bicycles, and pedestrians. And the crash rate? It is just soaring. Now, the railway's red and green system was being adapted for roads, but a major problem emerged real quick. Cars don't stop as predictably as trains on a track. Drivers were seeing the light instantly snap from green to red and were just slamming into each other in the middle of intersections. Enter William Potts. Potts was a Detroit police officer working right in the epicenter of the American car industry in 1920. He recognized that there desperately needed to be a buffer zone, an interval between go and stop, to give drivers adequate time to react and actually slow down. So he invented the first four-way, three-color traffic signal by adding the yellow light. Why yellow? Well, because it sits right between red and green on the visual spectrum and is incredibly highly visible, even in really poor lighting. It provided the absolute perfect psychological and visual bridge. But even with Potts's awesome invention, the country was still this patchwork of confusing rules. You could drive to one town and green meant go, and then in the very next town, you might see a completely different system. To stop the chaos, the National Conference on Street and Highway Safety began meeting in 1924. This massive effort eventually culminated in the 1935 Manual on Uniform Traffic Control Devices, or MUTCD. This document rigidly standardized the system we know today across the U.S. Red for stop, yellow for caution, green for go. It was a universal language created to save lives, stripping away the guesswork for drivers everywhere. We interact with traffic signals every single day, right? We completely take them for granted. But the next time you're driving in a heavy downpour and you see that glowing red orb cut through the mist, telling you to hit the brakes, just take a moment to appreciate it. You are relying on a deeply invisible infrastructure. You are being kept safe by 19th century wavelength physics, the evolutionary hardwiring of your own brain, the bravery of an exploded London police officer, and the hard, tragic lessons of a 1914 train crash. It really makes you wonder, what other everyday objects are hiding a secret history of blood, fire, and physics?